Okay, here's a little fan and the motor, and it's rated at 240 volt, and I want it to run on 120. I want to put it in my fireplace because fireplace, a gas fireplace, but it doesn't kick out the heat at all. So this is a perfect little fan to put in there. And I'll show you how this thing runs. The speed is just not there. So I'm going to hook this up to 120 and we'll see how that spins. Okay, I'm going to turn it on now. Very low rate. Barely feel a breeze. I mean, it is spinning, but motor's not built for 120 volt anyway. See if we can convert it. Just explain a little bit about this motor. It uses electromagnetic field to turn this fan. The power is connected here, and it's directly to copper windings that go around a core here. And due to the magnetic field, it actually spins the motor, and then in turn spins the fan. So if you want to convert these motors, and this is what I heard, and I hope this works, if you can manipulate these copper windings, it's just copper that's wound around, and I'll expose that to show you. But if you manipulate that copper winding, lengthen it or shorten it, you can change the speed of this fan. You can change the speed of this motor, how it interacts directly with the speed and RPMs of this motor. So hopefully this works. You know, I'm just going by theory. I'm just gonna take a chance on this, but since this is 240, I'm not sure what I'm going to get into as I expose this, but hopefully these windings, I can change this motor, because it needs it's just definitely running too slow. Hope that explains it. I know I'm not the greatest at explaining everything, but all I know is we can change the windings, we can change the motor to maybe run better for my purpose. So let's get into it. Okay, so here's another motor. So I had a secondary motor I'm going to take apart and experiment with. So it's all in pieces. Here's the coil from that motor. The coil goes in there. So I unwound this whole coil. That wasn't really my purpose, but I thought there was two coils in here, being a 240 volt motor. There'd be a primary coil and then an outer secondary coil, and I was going to go down to the primary coil and then put it back together. But there's just a single coil with about 2,000 wraps on here. So as I was unraveling it, you know, trying to keep it sorted in a box, but it's just exploding. But so I unraveled the whole thing, and then it was about 1,800, a little over 1,800, wraps around this, on this coil. So I went down to a little over 900 now, and cut this coil. So basically it's half a coil from the original, and I'm going to put it back in the motor and see what it does. And if you know about this copper winding material, there's a varnish on it, so I have to scrape off the varnish on the ends and then solder it together. I'm actually going to take it right to there. There's a little resistor in there. So all you have to do to get that varnish off is scratch it off. So I use this knife, and we just scratch that in until you get you can see that varnish is gone. Then it's ready for soldering. You can also test it with continuity, whether you got that end of the wire scratched off enough. So I got on continuity here. It'll beep if we have connection. See, this is all full of varnish, so this is non-conductive to each other. So we go to the wire. So nothing till we get to the end and where it's varnish is scratched off. We got continuity. So that'll work. Okay, it's soldered up. Let's put it together. Okay, I've got this motor back in the cage. Let's give it a test. That definitely is going a little bit of rubbing somewhere. That's definitely going twice the speed as it was before. Oh yeah, it's kicking out a lot of wind now. Jeez. I think this worked. Okay, I'm not done yet. I realize this thing is spinning backwards. It's spinning in this direction. It should be spinning in this direction, so it probably blows the wind out through this little chute. And that is most likely this coil here. I have to put it in the other direction. So let's try that. I reverse that coil. Just gonna apply power here. See if it spins the right way now. Nope. Jammed. Hang on. Let's give her another shot. Still not turning in the right direction. What the heck here? Yeah, I've noticed something with this. It takes a lot of wattage. So change it to watts. 44 watts. It's 44 before, 45 before. And amperage 0.71. That's actually 4 times what this other one was putting out. When I didn't adjust the coil. So adjusting this coil in half actually increased everything 4 times. So that speeds 4 times. Most likely amperage and the watts are. And I don't think this motor will sustain that because it does get hot. It does get quite hot when it's been running for a while. So, and the thing's still running in reverse. So, see what else I can do. So I don't know why I didn't think of this sooner. I just put the motor on the other side. The thing's putting out a lot of wind here now. Tremendous. I think this will work. This will work. Definitely matches similar item you put in a gas fireplace, so it'll cool off the firebox and then send the heat up and out to the room. So I am going to consider this success. I know it's a little buzzy, it's a little loud, but maybe we can work on that and see if that buzzing noise will go away. But okay, I wasn't happy with the motor the way it was. I actually added some coils, took it apart again, added some copper, and to try to get this RPMs slowed down, and the motor was getting so hot that probably wouldn't last. So let's try it out again, see what we get here. Right, could be fire, I don't know. Power going on. Okay, it's a little cage issue, the rubbing, but we do have a lot less RPMs. Zoom out. Breeze is not too bad. Let's check our meter here. gonna just go wattage. We're at 23. So it's actually what I wanted. I wanted double what the old one was, which was at 12 watts, and the other one we're up to 48. So I want somewhere in the middle. So that's 24. Could have been better. Could have been at 30, I think. Amps. 0.3 of an amp. So it dropped it quite a bit. Temperature is fine. It's just warm. Actually, you know, I think it would run better if it was a little faster. I'm finally done experimenting on this. Now I have it mounted in the fireplace. Sorry for poor lighting here, but it's in the back there. It's mounted. It wasn't the easiest thing to do, is mounted in there, but it's there. I just have a regular cord coming off it. Threw it a 15 amp breaker that installed, because this is still experimental, so be warned, experimental guys. So you're on your own doing this. All right, I take no liability. So yeah, we got it mounted on there. I did change the coils on it to increase the speed where it was last set. Wanted to get around 30 watts, and that's where it is. So I'll it's been working fine. It's great. I'll plug it in here for you, and we can check the meter, show you what I ended up with. On, runs fairly quiet actually. Pretty happy with it. You know, it's that sweet spot where it's cooling the firebox off. You know, it's creating enough breeze, kicks out the heat, quiet enough. It's not annoying, and I'll show you what numbers here. So, okay, there's your voltage, and we were trying to get 30 watts, which I wanted at 0.42 amps. And I charted this out, so I'll show you that. Kind of wrote down some numbers of how I experimented with this. This is full experimentation. I'm sure there's a formula out there to calculate, you know, how many coil wraps to output, but kind of like the experimental fact that I was just figuring out as I go. So that's happy with that. So I got my 30 watts, and like I said, it's quiet and running good, and so create enough breeze that it's blowing out the heat around the back of the firebox. Okay, here's my chicken scratch here. This is what I ended up at. Okay, first started with a fan. You know, it was originally 240 volts, converting it to 120. It was running at 0.17 amps, cooking out 12 watts at the 120. And with the original 1840 coils that were on the motor, and then I just halved it, so 920 wraps. Actually, 4 times the wattage came out of that, so it's not a 1-to-1 ratio whatsoever. So that was really sped up quite a bit. So I had to get a sweet spot. I experimented at I took a quarter from that, added a quarter, and it was 1380 down to 24 watts. Still wasn't happy, so somewhere in the middle, I chose 1240, see if I can get that around 30 watts, 30 to 32 watts, and achieved the 30 watts, and at an amperage of 0.42. Seemed to be a really good spot for that motor, for, you know, putting out enough but not being too noisy, and it won't overheat. So that's kind of some of my numbers. Like I said, there's got to be a formula for calculating the number of coils to what you want your output on that motor. I don't know that, but if anybody finds that, put that in the comments. But again, this is totally experimental. I'm satisfied with it, and probably won't do anything else with any other motor. But it's kind of, you know, how I roll. Just try things as they go, and you know, not too fanatical about one thing. Just try different electronic and electrical items. Anyway, thanks for watching. Take care, gang.